do one like that later. All right, so let's talk about the applied force. So the applied force we've already talked about somewhat. We talked about applying a force downward and upward on a box. So it's just a pushing force or a pulling force is all it is. A push or a pull. It's not generally a rope. It's like a physical push or pull. So let's just talk about a few examples. We've got a box here, and this is a 50 kilogram box. So what is that? Is that mass or weight? It's kilograms, so it should be mass. So the weight is going to be equal to 50 kilograms times 9.8 meters per second squared, which is going to be 490 newtons. So right now, it's sitting on this table, and we're going to apply a force of 20 newtons for 10 seconds. So let's just talk about what's happening. First of all, let's draw the vector diagram. It has weight, which is 490 newtons, and it has a normal force, which is equal to the weight in this case, because all of that forces add up to 0. It's supposed to be an N. Here we go. And you're going to push it with 20 newtons. So in the y direction, all of the forces in the y direction add up to 0. So Fn equals Fg, and they're both equal to 490 newtons. In the x direction, it is not balanced, so it's going to accelerate, and the force that's causing that, there's only one force, and that is Fa. That's 20 newtons, makes the 50 kilogram box accelerate. And that acceleration is going to be 20 divided by 50, which is 0.400 meters per second. Just trying to be consistent and round everything to 3 sig digs like you do on your homeworks. So what does that mean? It means that for 10 seconds, it's going to increase its speed, right? At 0.4 meters per second every second. So now, once I know that the acceleration is 0.400 meters per second, we assume that it starts from rest, and we're looking for the final velocity, and we know the time is 10 seconds. You can use a kinematics equation to solve this. That equation will be at Vf equals Vi plus At. And if I do my math and solve for Vf, it's already there. So Vf is just going to be equal to 0 plus 0.400 meters per second squared times 10 seconds. And Vf is going to be equal to 4.00 meters per second. So what did I do? I drew a vector diagram, labeled all my forces. My vectors are arrows pointing in the right directions. I then looked at what was going on in the y direction. If it is balanced, then the sum of all the y's equals 0, which means that anything in the up direction is equal to all the ones in the down direction. I looked in the x direction, and it's not balanced, so the net force is equal to the mass times the acceleration. And that mass times the acceleration the net force is the applied force that I'm pushing with. And I'm just setting that equal to ma and solving for a. All right, let's talk about what's going on that box on the incline, if we put it on the incline. Once again, we have a very common diagram that we're always going to draw. We're going to have the weight goes straight down. We're going to have a component that's perpendicular to the incline and a component that's as long as, kind of like the components of that vector, F parallel, and then we're going to have the normal force. So in the y direction, all of the forces are going to add up to 0. So the only ones that are in the y direction are Fn and F perpendicular. F perpendicular is the weight times cosine of the angle of the incline. F parallel is the weight times the sine of the incline. F G is mg. These are the three equations that we have. So Fn is going to be equal to the weight. Well, the weight is mg times cosine of theta, right? Mg. And F perpendicular is that weight times sine theta, times cosine theta. So it's going to be mg cosine theta. We've already found that, right? We know that mg is 490 newtons. So 490 newtons times the cosine of 30. And that should be 424 newtons. And in the x direction, it's going to accelerate. And the force that's doing that is F parallel. And F parallel is mg sine theta, which is equal to ma. And I want you to see something. Without putting any numbers, I can make this really easy equation. The m's cancel out. So really the acceleration, which is what we want to find, is equal to g times sine of the angle. It means it doesn't really matter how much mass is there if there's no friction. It's just g times sine of the angle. So 9.8 meters per second squared times sine of 30, which should be 4.90 meters per second squared. That is a 4. And then it wants to know how much force do I need to apply to keep from sliding it down the incline. Well, if I wanted to keep it from sliding down the incline, I would need to balance F parallel. So my applied force would have to be equal to F parallel, which is 490 newtons, times the sine of the angle, which would be 245 newtons. 245 newtons. All right. Let's talk about tension. So I've mentioned the word tension when I talked about pulling a rope. Our symbol for tension is T, and it's so any time we have a rope, that's the force that's in the rope, the pulling force of the rope. So let's talk about a rope, a box being pulled by a rope. And we want to talk about what force is causing its motion and the normal force acting on it and its acceleration. So it's once again on a table. It has weight, but now it has a tension. Notice I'm drawing this as an arrow. And that tension has an X component and a Y component, and then there's also the normal force. So what is the force that causes its motion? Well, the force that's going to cause its motion is the force that's not balanced, right? So that would be Tx. And Tx is just going to be T times cosine of the angle. And it says that 200 newtons is applied at an angle of 30 degrees. So 173 newtons is what's going to cause its motion. And it wants to know the normal force in it. Well, the normal force plus Ty has to balance out Fg. So the normal force is going to be Fg minus Ty. Well, Fg, this is a 50 kilogram clock. So mass equals 50 kilograms. Fg equals 50 kilograms times 9.8 equals 490 newtons. So this is 490 newtons minus Ty, which is T sine theta, or 200 sine of 30, which is 100 newtons. So this will be minus 100 newtons. So Fn is equal to 390 newtons. And then last, we want to know its acceleration. So, well, we already said that Tx is going to make it accelerate. So its acceleration is going to be Tx divided by m, which is going to be 173 newtons divided by 50 kilograms, 3.46 meters per second squared. All right, and the